Essential Security Protection Mechanisms, Jasdeep Sidhu and Yanko. Here's our overview. We will be talking about two sections in particular: the essential security protection mechanisms and security policy and computer architecture. In the first, we will cover the topics of technical mechanisms, layering, abstraction, data hiding, process isolation, hardware segmentation, and in the second, we will cover the topics of policy mechanisms, principle of least privilege, separation of privilege, and accountability, and we will end with our references. Technical mechanisms. Technical mechanisms are built-in implementations on the system, known as controls that are used by system designers. They are divided into 5 subcategories: layering, abstraction, data hiding, process isolation, and hardware segmentation. Layering. Layering means to separate hardware and software functionality into modular tiers. Depending on the complexity of an issue, such as reading a sector from a disk drive, which is contained to one layer, in this case the hardware layer, another layer such as the application layer is not directly affected by a change to another. They can use many different models, like the ring model or level model, which put data in the center with the protective layers around it to communicate together, forcing incoming data to go through stringent authentication and authorization checks to verify their integrity. For example, most systems use a form of layering as a way to protect system resources. A traditional kernel-based operating system, such as Unix, uses a layer 2 approach in which the system's resources are managed in a protected kernel and everything else runs in an outer layer known as the user space. If a process running in the user space wants to access a protected resource, such as a disk, it makes a request to the kernel layer to perform the action. Abstraction. Abstraction is a common term in the world of object-oriented design, describing when data is managed as a collection called an object. Objects are usually defined as classes that define the data and methods that can be used to access the object, since they have controls and operation rights. Methods provide a predictable way to access the object's data, which allows the entire data within the class to be managed as a unit that can enforce access controls and integrity of the data. For example, abstraction means that the details of something are hidden. Developers of applications do not know the amount of or type of memory that will be available in each and every system their code will be loaded on. If a developer had to be concerned with this type of detail, then their particular application would be able to work on only on the one system that maps to all her specifications. To allow for portability, the memory manager hides all of the memory issues and just provides the application with a memory segment. The application is able to run without having to know all the hairy details of an operating system and hardware it is running on. Data hiding. Important in the use of multi-level security systems to ensure data existing in one level of the system is not visible on another system. So sometimes access to data should not be provided, like in the event of data values within an application module that are used for internal calculations. In this case, no access methods are provided as an interface to this data. This is called data hiding because the data is hidden and accessible from the other layers. Process isolation is performed by operating systems and its jobs to enforce memory boundaries to protect the integrity of the process by preventing unauthorized access to data. All process isolation is required to maintain a high level of system trust, and without process isolation, there would be no way to prevent one process from spilling over into another process's memory space. Corrupting data or possibly making the whole system unstable to combat this and achieve process isolation, memory space is needed and the boundaries to prevent reading and writing of separate processes. We can use virtual machines as a simple way to achieve this if there's a large need for individuals. Process isolation has 2 major advantages. It prevents unauthorized data access. It protects the integrity of processes. Hardware segmentation. Systems of a higher trust level may need to implement hardware segmentation of the memory used by different processes. This means memory is separated physically instead of just logically. This adds another layer of protection to ensure that a lower privileged process does not access and modify a higher level process's memory space. Hardware segmentation takes process isolation one step further by mapping process to specific memory locations, which provides more security than logical processes isolation alone. A rare implementation since it can be costly and overly complex, so is mainly used for national security operations. Security policy and computer architecture. A security policy is a strategic tool that dictates how sensitive information and resources must be managed and protected. Security policies set the rules, practices, and procedures that define how the system decides to manage, protect, and distribute all sensitive information. This is an important element that has a major role in the defining the architecture and design of a system. Policy mechanisms. Policy mechanisms are a combination of security policies, which by definition is a statement of what is and what is not allowed, and a security mechanism, which is a method, tool, or procedure for enforcing a security policy. Principle of least privilege. The principle of least privilege ensures that only a minimum number of processes are authorized to run in supervisory mode. In other words, the principle of least privilege dictates that individuals have no more than the access that is strictly required for the performance of their duties. The principle of least privilege may also be referred to as the principle of minimum secured necessary access. For example, giving a user full permission on a network share rather than just read and modify rights to a specific directory open the doors not only for abuse of those privileges, for example, reading or copying other sensitive information on the network share, but also for costly mistakes, accidentally deleting a file or the entire directory. As a starting point, organizations should approach permissions with a deny all mentality, then add needed permissions as required. Separation of results. Separation of privilege. Separation of privilege is an information technology best practice applied by organizations to broadly separate users and processes based on different levels of trust needs and privilege requirements, which are known as granular access permissions, allowing for some process rights to be assigned with the ability to perform some supervisory actions, but without giving unrestricted access to the system. In the text, they put it simply by saying, think of separation of duties as the application of principle of least privilege to administrators. Separation of privilege, also called privilege separation, refers to segmentation of users' privileges across various separation users and accounts, breakup of privileges across various applications or system subcomponents and tasks and processes. For example, administrators assign different rights and permissions for each type of privileged operation. They grant specific processes only the privilege necessary to perform certain functions instead of granting them unrestricted access to the system. Accountability is a security principle indicating that individuals must be identifiable and must be held responsible for their actions. This is typically done by logging and analyzing audit data to help enforce accountability by keeping honest people honest. For some users, knowing that data is logged is not enough to provide accountability. They must know that the data is logged and audited and that sanctions may result from violation of the policy. Here are references that we use for this PowerPoint. Here is our contributions page discussing who did what and how. And finally, thank you. If you have any questions, feel free to find us at these emails. Otherwise, take care. Like and comment, subscribe.